for a coil which is placed and oriented like that. Okay, the question is this. Let me show you. We need to calculate the energy, my dear friends. The energy stored in the magnetic field when a current of 10 ampere produces a flux of 10 webers, right? So the flux given to you is phi is the flux which is given to you as 10 Weber, right? Now the question is that the energy stored in the magnetic field when a current of 10 ampere, it's also given that current is 10 ampere, and apart from it, what is the data which is given to us is that actually there are some magnetic fields. Okay, there are some magnetic fields. Okay, there are some magnetic field. Let us say these are the magnetic fields, right? Having some flux, and this is having certain coil. Right, this is like this. Okay, the question is that energy stored in the magnetic field when a current of 10 ampere produces a flux of 10 Weber through a closely wound coil of 200 turns. That means a coil is there, right? This is the coil. Okay, and this is making certain turns. Let me change the color of the pen. So this is making one turn. Let us say this is making one turn, then two turns, then three turns, then four turns. Okay, these are the coils. Okay, making that number of turns. Okay, so let me just put it like this. So total number of such turns are 10. 1 2 3 4 5 6 7. Let me make few more here. 8 9 and maybe here 10. Okay, so 10 turns of coil, right? So what is the meaning of writing it over here is that it's given that the Weber closely wound coil of not 10 turns, 200 in the question. The number of turns over here is 200 turns of coil, right? Now you know the formula that phi is equal to Li. You know the formula phi is equal to L into I, and flux is given to you as 10 Weber, right? It's given that 10 Weber through a closely wound coil of 200 turns, right? So the flux linked in all the turns will be equal to 200 turns. So 200 times this flux becomes this much of Weber. This is the total flux, isn't it? This will be the total flux. 200 into 10. You are not knowing the value of L, but you are knowing the value of I, 10 ampere, right? So from here we can get the value of L. What is the value of L? If you put the value of phi as 200 into 10, this will become 2000 equal to L into I equal to 10, right? This will give you the value of L. 100 will be cancelled, so you will get the value of L as equal to 200 Henry, right? This is your inductance, right? This is your inductance. Now L equal to 200 Henry. This is the value of L you have derived, right? So from here, what is the value of energy? What is the value of energy? This is the question to us. So my dear friends, if you remember the formula for a coil, the energy is always given as equal to half Lia square, isn't it? Half into L into I square, right? But and when it's a capacitor, it's half into C into V square, right? So if this is the formula which is readily available and known to you, this should be remembered, right? Just and we were not knowing the value of L, but we have calculated the value of L as equal to 200 Henry. This is the value of L, right? Now put it over here to get the energy, right? So from here, the energy, if we say energy is equal to half into L into I square, L into I square. This is the formula, right? You have calculated the value of L equal to 200. Just put it over here, right? So energy will be equal to half into 200 Henry, right? This value I am saying, this which we have calculated L, right? Into this 200, half into 200 into I square. What is the value of I? I is known to you, right? I is known to you. That is equal to 10, right? So when you just put up the value, this when you just put up the value, it will be 10 square, right? Because I is 10. So this will be giving you 2 will cancel this 2, then 100 into 100, right? So this will be equal to 10 K. So 10 kilojoule is the energy which will be stored into the coil, which is making how many tons? 200 tons. 200 tons. And this will be your answer, my dear friends. Thank you so much for watching. Bye bye.